Good morning, everyone. I hope everyone is fine and safe. We want to pick up the lessons where we left off. This is the carboxylic acids and derivatives. The class is the 3S, Life Science and General Science. Mr. Tony Massad with you, and the date today is the 11th of March 2020. Carboxylic acids, as shown in the first slide, they've got the general formula of CnH2nO2, structural formula of RCOOH, and there's an H written right next to the R, which is the alkyl group. This means that the R group could be replaced with H. And of course, the COOH, this is the functional group of the carboxylic acid, and it's known as the carboxyl group. The functional isomer of the carboxylic acid is the ester. Carboxylic acids, they start with N greater or equal to 1, and a reminder that the N is the number of carbons that we have in the carboxylic acid. The name of the carboxylic acid ends with oic acid. So for example, if you have 1 carbon methanoic acid, 2 carbons ethanoic acid, 3 carbons propanoic acid, and on and on. Carboxylic acids exhibit only skeletal isomers, which means that you cannot have positional isomers simply because you cannot change the position of the carboxyl group, which is always numbered 1. The next slide right here, I'm just presenting some examples on the naming of the carboxylic acids. The one on top is the CH3CH2COH. Since we have 3 carbons, it's propanoic acid. And more examples, the C6H5COOH, or the ring with the alternating double bonds inside the ring, COOH. Remember, ladies and gentlemen, I said it many times, the C6H5 is the same as the 6-carbon ring with an alternating double bond inside the ring. This is called benzoic acid. To stress, again, the carbon in the carboxyl group is always numbered 1. Some chemical reactions involving the carboxylic acids. Number 1, the reactions with calcium carbonate, CaCO3. The general equation is we need 2 molecules of the RCOOH plus 1 molecule of the calcium carbonate, which is a solid, producing RCOO taken twice Ca, which is an aqueous solution, plus CO2 plus water. Remember that the CO2 turns lime water turbid. That's the test for the release of carbon dioxide. And the RCOO minus, it's called the alkanoate ion. So for example, here, if you have like 2 carbons in it, it's called ethanoate ion. 3 carbons in it, a propanoate ion. 4 carbons in it, butanoate ion. Now in the reaction between the acid and the calcium carbonate, for example, we have like, let's just consider ethanoic acid plus the calcium carbonate. It is going to produce calcium ethanoate, and the reason why we have 2 of the ethanoate ions is because the Ca2 plus requires 2 of the ethanoate ions to form the ionic compound. Another example, with 4 carbons with the calcium, we call it calcium butanoate. Number 2, reaction with water. Carboxylic acids are considered weak acids, so the RCOOH plus H2O in reverse produces the RCOO minus plus H2O plus. Remember, according to Bronsted definition of the acid is any substance that donates an H plus, so the RCOH gives up the H plus to be gained by the H2O, which acts in this case as the base to produce the alkanoate ion and the H2O plus. Reaction with a strong base, OH minus, for example, sodium hydroxide or potassium hydroxide. The equation right here is a complete reaction. RCOOH represents the carboxylic acid and the OH minus represents the base, producing the alkanoate ion plus H2O. Now, number 4, we've got the reactions with metals, ladies and gentlemen. Metals such as sodium, iron, magnesium, aluminum, and so on and so forth. I chose 3 metals, the sodium and the calcium and the aluminum. And as we know that sodium belongs to column 1, so when it turns into an ion, it produces the Ni+. Calcium belongs to column 2, so when it changes into an ion, it becomes Ca2+. And Al belongs to column 13 or group 3. So when it converts to an ion, it becomes Al3 plus. So when you write the reaction with the carboxylic acid, you need one molecule of the carboxylic acid with sodium to produce the alkanoate ion with the Na plus half H2 to render the equation balanced. In case you have a metal that produces a cation with a 2 plus charge like calcium, you need 2 molecules of the acid to 2RCOH plus the calcium, producing 2RC00 minus Ca2 plus H2. And if you have a metal just like aluminum, which belongs to column 13 or group 3, which produces Al3 plus ions, then you require 3 RCOOHs plus the Al produces 3 RCOO minus comma Al3 plus 3 divided by 2 H2. Last but not least, we've got the esterification reaction. It's already discussed. The carboxylic acid with the alcohol producing the ester plus water. Of course, in this reaction, the carboxylic acid will be losing the OH and the alcohol will be losing the H, and of course OH and the H, they simply produce the water, and the two pieces, the piece from the acid and the piece from the alcohol, they simply combine together to form the ester. Remember or recall the characteristics of the esterification using carboxylic acids. It's limited, it's slow, and it's athermic. Limited could be replaced with reversible or incomplete. They all mean the same thing. Thank you so much.